Hello everyone, and welcome to this video on equations and functions, specifically the definition of a variable. In this video, I'm going to be doing some practice problems taken directly from a website called ck12.org. This is a website where you can practice mathematical concepts for free. All right. So I'm in there, adaptive practice, expressions and variables. I've already done a bunch of them prior to this, so I'm going to just get right into it here, and hopefully you can follow along. And of course, every new example that comes up, I'll be doing several of them. Pause the video and try to see if you can work it out yourself first before watching me do it. Okay, so this first example I'm looking at, a polygon has n sides. The second polygon has twice as many sides. Right, write an expression that represents the number of sides the second polygon has. Right. So I'll go to the scratch pad here. Right. Now they said that n was the number of sides of the polygon, right? That first polygon that was given. Ours has, twice as many sides. Now, whenever you see the word twice, that usually means, times two, right? Doubling the number of sides. So the number of sides that we're doubling here is, the number of sides of the polygon originally given, that was n, and ours has twice that many. So it's going to be n times 2 or 2 times n, and usually, multiplication, they're just written together like this, right? 2 times n. All right, so back up in the problem. I'm selecting C here, 2 times n. Check it out. Fantastic. All right. And this is what we're being asked to do for these exercises here with this introduction of definition of variables, right? A variable is just a letter or some symbol, represents a number, represents some quantity, and we're writing expressions, right, involving those quantities using addition, multiplication, subtraction, and what have you. Okay, so my next example, write an expression for the following situation. The amount of money Susan has in her coin purse in cents if it only contains quarters, dimes, and pennies. All right. So once again, I'll open up this scratch pad. Now, Susan has quarters. So I'm going to call this number of quarters. We have quarters, dimes, and pennies. These are unknown. I'm going to call the number of quarters, based on the results given to me in the multiple choice area. I'm going to call this Q, for quarters. And the number of nickels, I believe, right? It was quarters, dimes, and pennies. My apologies. So the number of dimes, I'll write next, right? Number of dimes, again, based on the choices I just saw from the multiple choice area, I'm going to call that D, right? The number of dimes she's carrying. And the number of pennies, right? Quarters, dimes, and pennies, I'll call that P, right? She has P pennies. Now, each quarter, right? Each quarter is 25 cents, right? This is 25 cents each. They're talking about the number of cents in Susan's purse. right? Number of dimes. Dimes are 10 cents each. And each penny is 1 cent. 1 cent each. So the total amount of money, right? The total amount of money in cents would be, you take how much money does she have? How many cents does she have in quarters? Well, if she has 25 cents for every single quarter, right, and she has Q quarters, then that's 25 times Q, right? Right? If Q were 1, 25 times 1 is 25. If Q were 2, 25 times 2, that's 50 cents, and so on, right? So it's 25 times the number of quarters. Then we're going to add to that the amount of money from the dimes, right? Now there's 10 cents a dime, so 10 times P, right? 10 times the number of dimes would be the amount of money in dimes. And then finally, right, we're going to add to this the amount of money in pennies. Now, each penny is only 1 cent. So that's just 1 times P. Now, usually when you write 1 times a variable, 1 times something, you don't need to write times 1 because it doesn't change the value. All right. So 1 times P or just P. And there we have it, right? This expression here represents the amount of money in cents that Susan would have in her purse. 25Q plus 10D plus 1P, and that would be selection A here. So just a couple more of these. I'll go through 5 of them. Next is write an equation for the following situation. A father earns $2,000 dividend from an oil investment and distributes it equally amongst his children. So distributing equally among people. If I have a certain amount of objects where I have $2,000, I have a certain quantity, and I would like to distribute it equally among so many people, that's going to be a division problem. I divide this amount of money equally among my children. So back to this scratch pad. So once again, based on the choices in the based on the multiple choice area, I'm seeing I and C, these variables showing up. All right. So the dividend from, the amount each child would get is one of these, right? I'll call I'll say that I is the amount each child will receive oops, sorry. I'm gonna hit the color thing there. All right, so it says receives. All right, let's do that again. Receives. And then there was also this variable C, right? Now C is going to represent the number of children, right? The amount of children that this father has. And so they said to us, the amount that he gives every child, he wants to give each child an equal amount of the $2,000, right? So what that means is we're taking the $2,000 and dividing it among these C children, right? 2,000 divided by C. For example, right? If we had the $2,000 and divided it, say this person had just 2 children, Well, doesn't that make sense that each would get $1,000, right? 2,000 divided by 2, I would give 1,000 to one child, 1,000 to the other child. That's a total of 2,000, right? Or 2,000, say the person had 4 children, right? 2,000 divided by 4, that's 500, right? So each of the 4 children would get $500. Okay, oops, my apologies. That was a little off screen here. But still, 2,000 divided by C is the amount given to each child if it's divided evenly. Okay. Here we're asked to write the following in a more condensed form by leaving out the multiplication symbol. Okay, so we have 3, then the multiplication symbol, then 1/4. Now you can write this in many ways. Multiplication can be represented in multiple ways. If I have 3 times 1/4, that's the same thing as, now one of the options they have up there is 3 within a 4. They put each of the factors in parentheses and have them touching like this. There's nothing in between them. There's no plus sign in between them, no minus sign, right? No division sign. If they're just touching, parentheses touching like this, that's multiplication. It's the same thing as this. You could also see 3 and then a little dot for the multiplication symbol times 1/4. All right. You might also see them actually multiply it out, right? This is the same thing as 3 over 1 times 1/4. When you multiply fractions, you multiply the numerators, multiply the denominators. This is 3/4. Now be careful. This here, when I write just 3 with the 1/4 right next to it and no parentheses or no multiplication symbol, this is called a mixed number. All right, this is a mixed number where you have a whole number and then a fraction touching it with no symbols, no parentheses, no multiplication symbols. This means addition. This means 3 plus 1/4, right? Which, if you were to add these up, get a common, when you add, you get a common denominator. This would be, multiplied by 4/4. This would be 12/4 plus 1/4. This would end up being 13/4, 13/4. All right, 3 and 1/4, not 3/4. So be careful. Right, be careful. If there's a whole number touching a fraction and there's no symbols around them, no symbols between them, it's representing a mixed number. It's representing addition. Right, but this up here is the one they want, right? They want us to write this. Okay, but again, any of these would be equivalent. 3 times 1/4, 3 times 1/4, 3 times 1/4, or just 3/4. Right? Every single one of those is the same. So back up here, this is the only one that's equivalent E, right, to the thing that was given to us. All right, so I'll do just one more example. So again, we're asked to write the following in a more condensed way, leaving out multiplication. Right, 6 times n. We saw this in the very first example of this video, right, where it was 2 times n. You can just put them next to each other. When one of the factors is a variable, 6 times n is the same thing as 6 times n like this, where you just touch them, or you could just write 6n. Something that's equivalent to this would be 6, 6 times n. I could write as 6 times n. I could write as 6 times n, or I could just write as 6n. All of these mean the same thing. And I know you might be thinking, well, what about you said, when it was 3 1/4, 3 1/4, that was addition when they were touching and there were no symbols. Well, that's when you have a whole number and a fraction written out next to each other as a mixed number. This here, one of them is a variable. This is implied to be multiplication, right? When you have 6 times n like this. So any of these would be equivalent to 6 times n. So the only one of these choices here that matches that would be equivalent to 6 times n is this second one here. Okay. All right, and so I feel like that's a pretty good intro. We've just talked about expressing variables, writing variables, using variables to represent certain quantities like Q for quarters, D for dimes, P for pennies. All right. Very often the variable that's used is n for number or x. You'll see a lot of x's and y's to represent quantities, but it could be really any symbol you wish. Right. And of course, these 5 aren't all of them. Again, I would highly recommend going to ck12.org. Create an account, and you can do all this practice on your own in their Algebra 1 course for free. So get to practicing, and hope you have a good time with it. Thank you very much for watching.